You know that if you smash the like button, subscribe, and click the notification bell, you're more likely to win the lottery? So what are you waiting for?
In his epic saga, The Inferno, the Italian poet Dante tells of Ulysses, the Greek hero who fought in the Trojan War and spent 20 adventurous years wandering the earth before returning home. But as Dante relates it, Ulysses, bored with domestic life, set off on still another voyage of discovery, a voyage toward an uninhabited world beyond the sun. In October of 1990, another Ulysses will begin an unprecedented voyage of exploration. This modern Ulysses is a spacecraft, bound for a region of our solar system never before explored, the region above the sun's poles. Stars. Uncounted billions grace our night skies. But only one holds dominion over the earth. It is the star we call the sun, the giver of light, of warmth, of life itself. The ancients called it the perfect fire. The sun is the only star we can see in the daytime, and the only one close enough to study in detail. It therefore provides scientists a unique window for the study of stars and the complex processes that go on within and around them. In recent decades, astronomers, aided by increasingly sophisticated instruments, some Earth-based, some lofted into space above Earth's obscuring atmosphere, have found our sun to be an exceedingly complex star with many faces. But scientists have never been able to observe a most important region of the sun, its poles. Even instruments on spacecraft are unable to see over the top of this great sphere. That's because until now we could study the sun only from within the ecliptic plane, an imaginary, nearly flat plane in which the Earth and the other planets orbit the sun. Yet scientists think our understanding of the sun would be vastly increased if we could observe it from above its poles. That is the goal of Ulysses, a joint mission between NASA and the European Space Agency, ESA. Willis Meeks is American Ulysses project manager.
Ulysses is a one-of-a-kind mission in that it's the first time that we have a chance to fly a spacecraft over the sun's poles to give us a look at the solar system from that direction. We're also going to look at the total sun's environment. We're studying something called a heliosphere, which is made up of all the things influenced by our sun. It's a joint mission with NASA and the European Space Agency. The Europeans provide a spacecraft. We provide a launch vehicle and a launch facility. The science investigations are split right down the middle. The instruments, there are 9 of them, hardware instruments. We provide half, and the Europeans provide the other half. The mission will be flown from right here at JPL.
Launch is scheduled for October 1990. The American Space Shuttle Discovery will first carry Ulysses into orbit around the Earth. There, Ulysses will be released from the shuttle's cargo bay. After the shuttle has withdrawn to a safe distance, 2 powerful rocket motors will fire and send Ulysses on its way. It will take nearly 4 years to get to the sun. This long journey is made necessary by the Earth's own orbital motion around the sun. Dr. Edgar Page, European Science Coordinator, explains.
Well, getting out of the ecliptic plane is not very easy. It requires a lot of launch vehicle energy. And I suppose that's one of the reasons we haven't done the mission before now. Now, what's the reason for this? Well, most normal launches take advantage of the orbital velocity of the Earth. They go along in the same direction. But this time, of course, we can't do that. We have to get ourselves perpendicular to the velocity of the Earth. We want out of the ecliptic plane. Now, the energy available from even a NASA shuttle launch is not sufficient to do that. So we have to ask for some help, and we get that from the giant planet Jupiter. We start from Earth, we go fast towards Jupiter, and then as we get close to Jupiter, Jupiter reaches out its gravity hand and grabs us and pulls us round from its north pole to its south pole and sends us off south of the ecliptic plane back towards the Sun.
Throughout the mission, NASA's Deep Space Network will track Ulysses, receiving data from previously unexplored regions of our solar system for analysis by Earth-bound astronomers. Scientists are sure to reap a rich scientific harvest as Ulysses and its 9 instruments explore previously unreachable regions of the Sun's domain. Dr. Edward Smith is American project scientist.
Basically, we're interested in making observations over the poles of the Sun, something which has never been done before. We have a lot of reasons for wanting to do that, and many reasons for thinking that conditions in that particular region of space are going to be very different than the kinds of conditions we've been sampling over the last 20 or 30 years. We have been making measurements in a flat, two-dimensional plane when the object we're really trying to understand is basically three-dimensional. And the object of this mission now is to extend our knowledge into that third dimension. Once we have that knowledge, we'll be in a better position to reevaluate the complicated conditions that we find near the solar equator.
Its mission will carry Ulysses over both of the Sun's poles to probe the Sun's corona, the diaphanous crown that we see only during an eclipse. The solar wind, a gale of charged particles that stream away from the Sun, and the tangled magnetic field which is carried into space by the solar wind. Finally, some of Ulysses' instruments will detect and measure cosmic rays coming from the deeper reaches of our Milky Way galaxy. The Sun, as we have come to know, is far from being the perfect fire the ancients believed it to be. It is instead a seething thermonuclear cauldron. Vast quantities of energy burst from the interior to create unimaginable turmoil at the surface. And as the energy pours outward across space, it carries ever-shifting electric and magnetic fields throughout the solar system. What complicates matters even more is that the Sun rotates every 27 days, and material at the equator rotates faster than material at the poles. As a result, the Sun's magnetic and electrical fields at the equator become tangled and hopelessly complex. Still more complexities arise in the constantly shifting corona. Even before spacecraft, scientists theorized that there was a strong relation between the corona and the solar wind. This relation became clear after spacecraft made it possible to observe the Sun from above the Earth's atmosphere. That's when scientists discovered huge tears in the corona. These coronal holes, here seen as dark patches, are the source of the solar wind. Low and high energy particles burst outward from these vast regions at speeds of up to 1,000 kilometers per second. Solar wind particles move at many different speeds, and so the fast particles bunch up behind the slower ones and overtake them. The result is a traffic jam that snarls the magnetic field lines around the Sun's equator into a tangle that twists and knots and becomes ever harder to understand. Ulysses scientists will also study particles that originate during solar flares. Solar flares are the most catastrophic and energetic events on the Sun. The particles they yield have extremely high energies. These high-energy particles explode outward, leaping from one magnetic field line to another, further distorting the picture around the sun's equator. But over the poles, there should be less turmoil, and therefore greater simplicity. That simplicity should bring valuable insight into processes in the corona. While Ulysses is near the poles, it will also measure cosmic rays, particles from dying suns far more distant than our own. Cosmic rays are born in the cataclysm of supernovas, old stars which suddenly explode with unimaginable violence. Hurled across space with incredible energy, cosmic rays bear the signature of the events that formed them. But cosmic rays entering the solar system near the equator interact with the solar wind and the sun's magnetic field. As a result, they are changed so dramatically as to be nearly unrecognizable. Above the poles, however, cosmic rays should change very little, enabling us to understand the messages of cosmic events long past.
I sometimes get asked why we do missions like Ulysses. Well, humans are curious beings, and we like to know what's over the next hill, so to speak. And just like in Dante's story, Ulysses went off to explore unknown lands. The Ulysses spacecraft is our way of exploring unknown regions of space. And our reward will be a better understanding of the environment in which the Earth moves, and also a better understanding of that star that means so much to us, the sun.
Did you know that if you smash the like button, subscribe, and click the notification bell, you're more likely to win the lottery? So what are you waiting for?